ABC is a triangle with AB equal to 5.4 centimeters, angle BAC is 32 degrees, and BC is 3 centimeters. Show that there are two possible angles for two possible values for angle ACB, and draw both possible triangles ABC, showing all lengths and angles. I think a sketch might help here. It doesn't matter whether it's in any way accurate or not. So if I say that this is A, B, C, this side is 5.4, BC is 3, angle ACB is this one, that's what we're trying to find. BAC is this one here, and that's 32 degrees. So, if this side is C, this is little c. If this is A, this is little a. We know both A and A, so we're going to use the sine rule. And I'm going to use that sine of C over C is equal to sine of A over A. So, let's just call this x or something. So we can say sine x over 5.4 is equal to sine 32 over 3. Now, let's just solve that on the calculator. So action advanced solve. So I'm going to have sine of x over 5.4, and I'm going to put that equal to the sine of 32 divided by 3. Now, actually, before I hit execute on that, I'm going to do given that x is between 0 and 180. After all, we're working in a triangle, so it must be. And let's see what answers we get. So we get 107.5 and 72.5. Now both of those are actually possible answers, because this angle here is 32. 107.5 add 32 is less than 180, so we can certainly get a triangle there, and of course the acute angle is bound to work. So we have two possible triangles, we want to draw them both. So we have one triangle with the obtuse angle just here. And so this one here is 107.5. We know that this angle up here is 32. And this side is 5.4. This one is 3. So the third angle here, we know that the sum of the angles is 180. So we do 180. Take away 107.5, take away 32, and that gives us this angle here as 40.5, and then we can work out this side here, again using the sine rule. So if we just call this one y, then we can use that. On here I'll put it in as x. So let's just get rid of that for a second. So action advanced solve, and I'll put it in as x here, so that I don't have to say given that we're solving for y or anything like that. It'll automatically solve for x. So that's x over the angle opposite that, which is sine 40.5, and then we'll put that equal to, let's use the ones that we originally knew, that's more accurate. So that's going to be 3 over sine 32, and execute, and that gives me 3.68. So let's say that's 3.68, and all of these were centimeters, I believe. So that's the first triangle. Now the second triangle has the acute angle 72.5 at that corner. So this is 72.5 now. Of course, this angle up here is still 32. This is 5.4. This is 3. And so we need this angle here, and we need this side up here. So the angle's easy enough. We're just going to do 180, take away the two angles we know. So we know the 32, we know the 72.5. So that's 75.5 here. So then we want to find Z. So action, advanced, solve. So the Z up there, now remember on the calculator I'll call it X because it automatically solves for X, don't have to tell it to. Sine 75.5, and that's going to be equal to, and again we'll use the information that we were given, so we'll use the 3 over the angle opposite, so that will be sine of 32, and execute, and we get 5.48, and we'd expect that to be the longest side because it's opposite the largest angle. So these are the two possible triangles from the information given. Because you can get more than one triangle from the same information, this is known as the ambiguous case.